Thank you, Stan. Today we're going to be talking about modeling techniques that can help us out on the simulation side. Um, and as if you've seen some of our other webinars, you've kind of seen this consumption gap already in here, but kind of a brief overview of this is basically if we're looking at this chart here, we can kind of see the ability of customers to consume features is at the bottom versus as time goes by, the complexity of all the products out there, whether it's in computers versus cars, mobile phones, all that stuff out there is starting to get more and more complex in there. And so a lot of us, as we start going through technology, will find a way of doing it and we'll stick with that. And we won't take advantage of some of the complex features that are out there. And that's where actually D3 is coming into it. We want to try to fill in this gap here so we know where there's features out there that we can actually help with so that way you guys are aware of what's going on with it. So today I'm actually going to talk about helpful tools that can help define forces and constraints. We're going to look at some helping with contacts between parts, just some simple options that can help save time on the simulation side of it, along with just being able to check your model and how we want to control the assemblies to help with the simulation in there. Okay, today we want to start off talking about how we can use the split tool to help with the FEA side of stuff. Now, depending on if we're using sim mechanical, which I'm going to use here, versus CFD, versus another FEA software, it's all going to be very similar tricks we can do inside the CAD model. So looking at this part, we can see we need to actually hold this thing with bolts and washer as there's pressure built up on the back side of this. So to actually set that, we don't want to select this whole face in here, so we can use the split tool to actually sketch our patch on here so that we know it's going to be sitting about that size, and we want to split this thing from that sketch to that face. So that way we have a selectable surface out here. And the pressure's not on this whole outside face, so we're probably going to do the exact same thing on this side. We want to come out here, make this 60. So we know exactly how our patch is in here. Let's split that one more time, that sketch to that face. Now I have selectable surfaces. So if I were to pull this over onto the FEA side of it, what we'll see is when it comes through here, very similar geometry here, but now I can pick this face, I can pick this face separately in there too. So if I mesh that, we'll be able to see everything shows up perfectly the way we want to. Now, once this meshes, we can see in here that we've got almost 1,000 elements in there. And we know if we're dealing with FEA, the more elements, the longer it takes in there. But if we look at this thing, it's very much symmetrical in here, so we could actually just take a fraction of this thing and do the FEA on. So we can use our split tool back in Inventor just a little bit differently to accomplish that. So if I use split, I'm going to split part this time and just base off our origin planes here. Cut that one off, cut the lower part off. And just for the fun of it, I got to put this other patch on this hole here too. Go up to split one more time, pick that base, and we're good. So I want to split that back over into sim mechanical. Now, when this comes back across, we can actually see here that's got 562 elements on it, so it's a little bit smaller in there. So what we need to do now is actually put our patches on here. We're actually going to fix those two surfaces. Now, since we're treating this as a mirrored feature, I need to come in here and tell it we're actually mirroring about those planes in there. Do that. X symmetry. And we'll add this one as Y symmetry. And then we're going to come back here and actually add a pressure to the back of it. 20. And hit OK. So now if I run this thing, it's going to solve this, and you can see if it's running at a quarter of the model versus the whole model, it will be a little bit quicker, even though this one is a pretty simple model. There won't be too much of a difference between the full model and the quarter section here. But as we see the results here, all of a sudden we see that, hey, it's all back to one piece in here. And that's just because I had these mirror planes turned on in here, so we can see the section as we created it here, but we can also turn these mirror planes on, so that way we can get a representation of what it looks like if it was whole in there. Okay, the next thing we want to look at here is dealing with contacts between parts. Now this one we're just doing a two-part assembly where we got two plates butted up against each other. So I want to take those over to some mechanical first. And when it comes across here, we're going to go ahead and mesh this. So we want to set this up how we want to run the test first. So I want to come in here and actually take this and put a fixed constraint on it. And then over on this end, we're just going to say we're pushing a force down on it. Okay, 200 pounds in the Y direction. So that way we're pushing this down. Now, the default, if I just took everything as it is and hit run, it's going to treat this as completely bonded to the other plate. So I mean across the whole face that is touching in there, which might not be the most accurate because there's no way to actually bond that unless we're using glue. Now, when this solves, we can kind of see it's going to treat this thing as completely solid across this thickness in there. Now, if we want to represent this a little bit differently in there, we can actually kind of go back to Inventor and do a little work with the split surfaces in there. So kind of jumping back to the split tool is in these parts, I've got these already predefined in here. I've got this stepped in so that I know how far I want my weld to go in. We can have those set up in there. And same thing on this part, same thing, have splits set up on that side. So if I bring those back over to Sim Mechanical, let that remesh there, and we can kind of see our forces are still there. And sometimes you got to pay attention if it kicks off one of these constraints in here. We need to add that fixed constraint back in there. So now on this one, the default contact is set to bonded. I don't want that anymore. I want to actually say, well, it's surface contact. So anything it sees between all these faces is surface contact unless I define something. So if I pick that surface, this surface, actually go down to contact, make that bonded. And the same thing if I pick this surface and this surface, go down to contact and bonded. So we'll run it that way first, see what it looks like. So that way we can kind of control this more as a weld down the sides of this thing and see what it looks like in there. There we go. So you can kind of see a little bit more stress on those sides where we actually have it bonded in there, where in here we're actually getting a lift off where it's actually lifting away from that face in there. Now if that was the only weld that's put on there, it's pretty accurate in there, so you can kind of see the representation of where those were being held at in there. So it's very important on some of this stuff to understand how we're actually constraining these to each other. Even though they're face to face, the default bonded might be a little too strong for what it's actually doing in there. Now, a couple other tricks in there, you can kind of see where I came in here and I specifically said between this face and this face. It can be hard to pick those underside faces that are on there. So one thing you can actually do in Sim Mechanical, inside your options here, there's some CAD import options. These two I kind of use every once in a while is the split surface on import, which is going to see the faces touching and it'll actually do the split surfaces for you, and then automatically generate contact pairs. So that way, whatever contacts it sees, it's going to generate them for me. So I'll say OK and OK on this one. And just to show you, let me turn off this part here. So you can kind of see these selectable faces out there. If I go back to Inventor, don't change anything in Inventor, just say I want to relaunch this. Just going to bring this in, and left that one part off, you can kind of see now that it actually saw the surfaces that we're touching, and it automatically splits those faces. So you can see there's different selectable faces in here. Turn that one back on here. See it? But it also generated all the contact pairs so that I can actually see which ones are which. So I can control them better than having to select them. I can actually just see them from the list in here. It's just preference in there, but sometimes I'd like to see what it generated versus just assuming that it got it in there. So. Next thing I want to look at here is actually taking a model that may have came from a different software package or step file. So that way when we brought it into Inventor, we've got just a solid body in here. And I want to run an FEA on this thing. So the first thing, if I look at this, yeah, it looks good. Pretty simple in here. So if I go out, go to simulation, and throw that over to sim mechanical. Everything looks fine. It meshes it. It should be good to kind of apply any loads we want to it. But one thing I always want to do, especially if I'm getting models from somebody else or somewhere I'm translating it, is, yeah, the first thing is a visual check. But the other thing I always like to do, I always recommend to, is go to your view, turn it to wireframe. See if there's anything hidden inside that part. You can kind of see right here that there's kind of a couple slivers inside this part that might cause issues. They might not, but I want a clean model before I go into FEA in there. So on some of these, and this was on purpose so I know exactly they were in there, but I need to clean these out. Since there's no features over here to find that, we got to use some different tools to get to those. One I usually use is delete face. Delete face allows me to come in here and pick through, so I can pick these 4 faces. And I want to make sure I hit heal. If I don't hit heal, it'll turn it into a surface. Get rid of that one. You can see it actually caused a little bit of an issue here, but it's just graphics related. Roll over to this side, do the same thing. And you can see, you can notice I actually picked the outside just to get past that selection, then hold shift to unselect it so it's not part of it. That way when I heal it, now I've got those pieces gone from the inside. Change that back here. So that way, delete face is a great tool to get rid of some features that might be internal slivers that we don't have features for. It's also a great tool to just come out here and say, well, if I don't want this fillet on here, do delete face, pick that one, and tell it to heal. I'll get rid of those. Same concept if I didn't want this step down, delete face and heal, do the same thing. Now, and do that. Some of the newer features in here, the direct edit, will do the same thing if you select delete. So you can pick those faces, and it'll give you a preview before you hit apply. So that way, if I pick this and say I want to delete it, it kind of shows me that seam in there. So they both accomplish the same thing. It's just direct is going to give you the visual feedback in there. Where delete face, you just kind of have to click it and hope it works. If it doesn't, of course, we can hit undo. So that way, when I take this part, I can say, well, now it's cleaned up a little bit. Let's take it back over there. Now, when this comes across the meshing side of this, the one thing I just want to point out on this side is looking at a model, especially when you get curved features, you can kind of see the mesh looks a little weird. Some of the lines are disappearing. When it meshes, it's actually creating the mesh and keeping the CAD geometry on at the same time. You can actually go to View, turn off CAD surfaces so you only see the mesh, and you won't see those extra pieces and all the lines that disappear in there. Final thing I want to look at here is how we can manipulate assemblies to help with FEAs. First rule of thumb here is a production model is not the same thing as an FEA model. They may send you the assembly, but we don't want to touch the production side of it. Because we might manipulate this thing for an FEA that's a little bit different than what they want with production. So we want to get this into our own environment. Best thing to do is always when you come up, get the new assembly, do a pack and go. Take this thing out to a spot that you're doing FEA, that you have a project specified just for FEAs in there. So that way I know I'm working on my copy. I'm not adjusting, modifying anything from the production side of it. So that way when I have my own location, I'll keep just the model files, and we can do search now. So it knows how many files we need, hit start, and it creates it out there. And I've already copied this one over here. So a lot of this one gets into the fact that there's some stuff that if I'm worried about an FEA on this cage to make sure it's good enough, there's some things I don't need. I need to know the weight of it. We can find the weight of it. But some of the piping, yeah, I don't need it. I can just knock it out of my assembly here. This tank here, do I really need it? Am I concerned about the actual FEA on the tank or just the frame? If I'm just worried about the frame, I don't need to worry about meshing this model. All I need to know is what the weight of it is and where it sits on this pan. So that way, the easy way just goes back to our whole split surfaces. I can activate this part, create a sketch on here. So that way, I know exactly where it sits at here. Pick those edges, bring those in, and make this easy. All I'm going to do is put my own rectangle in there and just align it. So get the closed gaps in there. So that way, we jump straight back to our split tool. We can split this rectangle across that face. Now I've got that selectable patch. I know the weight of this. Well, it's gone. Get rid of those. Same thing with this motor. Those ribs and those features on there will take a lot of time inside of FEA. If I'm not doing an FEA on this motor, I just need to know the weight and where it sits. Great, let's get rid of it. So we just need to know where it's sitting at. So again, just activating this part, creating a sketch in here, and using project geometry to pull in where these legs are. And then sometimes it might be easier to actually open these up by themselves so we can see where it is. We'll create a sketch on this side too. Actually, probably we'll just edit this sketch here and project up that face as well. So that way we can just draw two simple rectangles, and then we can align them to patches on that side and that side, and then repeat this process on this side. So that way I can use the split tool, split that sketch against these. And you'll notice you can only use one closed sketch at a time. So when you use it, you've got to turn it back on. So I can split it one more time over on this side. There, so now we have our 4 spots in there where we can actually hold on. We know where that weight is. So that way we can set the part. Okay, he's gone now. So that way you can kind of see that same thing on the bottom here. I'm not going to actually have you watch me do this one again, but if I know where the wheels are, I can just create a patch on that frame so I know where to hold it. Do I really need this wheel in there? Am I concerned about it? If not, delete it. So that way we kind of clean this up and run the FEA on what we need to run it on. Don't waste the meshing time on parts that have a lot of features that we don't need. And it gets down to the part level too of taking features out that you don't need. A lot of these, look at this one, yeah, we don't need that switch. I get the patch where this thing sits at, get the weight of it, put it on there. So it's a lot easier to run an FEA on this versus having all those parts out there. So that way, if I went up here to simulation, went out to sim mechanical, pull in just this instead of having to worry about all those other features in there. So hopefully you guys gained something out of this so that we can actually do a lot of work on the CAD side before we actually go out to the FEA to help with the FEA side of it. So if we can save time on the FEA side, let's worry about the CAD models, get them prepared, and then go do the FEA.